Good evening, Don Emilio here, teacher of physics and chemistry, SEC Dublin International School. I'm going to explain today escape velocity. What is escape velocity? Escape velocity is the velocity you need to leave the gravity of a planet, an object. You know, gravity is universal. Everything has gravity. It's one of the four fundamental forces or interactions. And let's say, for example, Earth. How can we leave Earth without getting dragged into it again? So we need a velocity, something that makes us escape from that attraction. Okay. We will see further that gravity is not a force. We call it like this, but it's not a force. Okay. In this video, I'm not going to explain that. I'm just going to explain the escape velocity. All right. How can we see the formula? Usually, the formula of escape velocity, we just represent it like the v of velocity, and you can see escape like this. Okay. This is usually the formula, escape velocity, and then you could see. Now we start with the mathematics, like 2 multiplying the constant of gravity, the mass of the object, over the radius of the object. Okay, so remember we have g here. We know it's a constant. G is the gravitational constant. So for this reason, we're going to work with it separately. Another way, an easier way without mathematics to see this equation can be, yes, we remove this because we're going to use mathematics, so we can remove this and we can just add this, and in the final result, well, we will just do it. So now, what is velocity of escape? So let's see. We have the number 2. Number 2 doesn't work here. So we are just going to see if this is a velocity after applying the formula. So number 2, we don't need it. Why? Because it doesn't have unit. It's not like mass. What is mass? Mass is kilogram. That's the unit of mass. But the number 2 doesn't have a unit. So we don't touch it. G, we know G. G is Newton meter square over kilogram square. And all this multiplied by meter, that is the mass, that is kilogram. Of course, all this over, now we continue with the fraction, radius, that is meter. Okay, but this looks pretty hard to understand. You need to know mathematics. At this point, I'm sure you know it anyway, but let's make it simple. That's the point of physics, is to make things simple. Okay, so we're going to put everything in one line so we can all see it clear. Okay, so we could say that velocity of escape, that is here, velocity of escape is equal to this. But obviously, velocity escape to the square. Okay, so we continue, and we are going to put this, let's say, in one line. For that line, we will need, for example, here, Newton. We have Newton. Let's put it in one line, we said. All right, so I'm going to bring it down a little bit. So this will be Newton. We all know a Newton is kilogram meter square second. So Newton, doesn't matter, Newton, meter square. All right, now we have here kilogram square, so we put it in one line. So if we're going to bring it up, we put kilogram square in negative. So now we know this one, when this goes up, is in negative. And we have as well kilogram. Okay, so kilogram as well, so kilogram. And then we have this one, meter. So radius is in meter, very good. Now we start playing with this. We're going to start playing with this. We know what we're asking is to calculate exactly a velocity. That's what we are asking here, a velocity. We need to keep that in mind, that this is a velocity. So what is the unit of velocity? That's the first question, because you know that if they're asking for a force, the result must be in newtons. That's obvious. It's a force, must be newtons. Okay, that works like that. Okay, it's a distance, must be meters, like radius in this case. So So let's start putting things in order, okay? This formula, the Newton here, we know is a kilogram meter square second. So this formula, we're gonna rewrite it here, okay? So we cannot take a lot of space. Let me put it here, okay? That arrow is a very big, well, let's leave it like this. Newton, a Newton we know is a kilogram meter square seconds. Well, all this is a Newton. Following the second law of Newton, that means force equals mass times acceleration. Following that, mass is kilogram and acceleration is meter square seconds. All together, multiplied, is a Newton. Kilogram meter square second is a Newton. So we have here a Newton. What's next? Meter square second. So we put it here. Meter square, not second, meter square. We have now kilogram square negative. So we have kilogram. Negative and another kilogram. And then we have meter. Meter is down under, so we should put here, this meter should be in negative, okay? Because as you can see in the fraction is in the bottom part. That means when we pass it to one line, it passes as a negative exponent. So now we got it, kilogram, meter square second, kilogram, and I'm forgetting the meter, the radius, so meter minus 1. And let's start solving, okay? Let's start solving. We have how many kilograms? Let's start with the kilograms. Let's move this a little bit, okay? So everybody can see this. So let's move this a little bit. All right. Let's say there's a kilogram. How many kilograms I have? Kilograms, one in positive. Minus 2 plus 1, so kilogram. In positive, I have two of them, kilogram and kilogram. And kilogram minus 2, so the kilograms are out. Goodbye, kilograms. I have minus 2, and I have 1 plus 1 is 2. So minus 2, so goodbye, kilograms. Now we have meter. Meter plus 1. And I have meter plus 2. That means meter 3 minus 1. Or I have meter 1, goodbye, and I have meter minus 1, goodbye. And then I have only square meters. Now I have second to the negative. Very good. So as you can see, after removing everything, this is all I have. This is all I have. Very interesting point. Have you seen what I have here? Can we represent this as a fraction? Of course we can. If we are going to represent this as a fraction, it's going to be meter square over square seconds. Very good. And as you can see here, this is minus 2, the exponent. Why I pass it here as a positive? Because that's how maths work. Because in this case, they are multiplying. If you want to put them dividing as a fraction, you change the exponent. That's mathematics, okay? The rule of exponents. You will go there. So now we know the velocity of escape. Velocity escape to the square is equal to meter square over second square. So how can we remove this? You know, if you've done maths, you will know that this will cancel both of them, meaning that the final solution will be velocity escape equal meter over seconds, or you can put it as meter. 1 second, this looks like it's going very easy, very slow today. Minus 1. So now